Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today we're going to be doing Unit 8, Lesson number 6 on the quadratic formula. Now, you saw the quadratic formula back in Common Core Algebra 1, and you may have even had some teachers have you use it in Common Core Geometry when you were trying to solve systems of equations algebraically. But it may have also been an entire year since you've seen it. So we're going to use this lesson to review the quadratic formula, how it works, and what it can do for us. So let's get right into it. All right, exercise 1 asks us to solve the following quadratic equation for all values of x by first completing the square on the quadratic expression. Express your answers in simplest radical form. All right. So we've got a bunch of different things here. We've got completing the square, we've got simplest radical form, etc. So I'm going to rewrite the problem right here. X squared minus 6x plus 1 equals 0. Now I could try to use the zero product law, but it would be very, very difficult in this case. Plus, they said to do it by completing the square. So remember how that's going to work. What I'm going to do is I'm going to take half of that negative 6. I know we just did this a little while ago. And then I'm going to square it, and I'm going to get 9. So I'm going to add 9 on. All right. I also have the plus 1. Now, what I'm going to also do is I'm going to add 9 to the other side. So what I'm really doing is just adding the same quantity to both sides. I'm then going to group these first 3 terms together and leave the 1 out. It is the loneliest number. I can now factor this because it is a perfect square as x minus 3 squared plus 1 equals 9. Now I want to emphasize that these two equations are equivalent. All right, they're the same equation. But they're written in very different forms. And the beautiful thing about this form is that I can now solve for x by simply undoing everything that's been done to it, right? I've subtracted 3, I've squared, and I've added 1. So the first thing I'm going to do is subtract 1 from both sides. That's going to leave me with x minus 3, quantity squared equals 8. I'm now going to undo the squaring by taking the square root. But recall that if I have something like x squared equals 16 and I take the square root, I'm going to get x equals plus or minus 4. So I'm going to have the same thing here. I'm going to get plus or minus the square root of 8. Now notice this simplest radical form business. I could at this point simplify the square root of 8, or I could wait until after I add the 3. I think I'm going to simplify it right now. Right? And this is what we did in the last lesson. We're going to break up the square root of 8 as the square root of 4 square root of 2. Bring this over here. Then I'll have x minus 3 equals plus or minus, we don't want to lose that, 2 root 2. I'll add 3 to both sides. Now, here's where a lot of students can get thrown off. Some students will think, I should add the 3 to the 2, or add 3 to the negative 2. But I actually am just going to leave it like this, 3 plus or minus 2 times the square root of 2. You see, I can't combine this number with this number. Okay, I can't combine those for a couple reasons. Number one, it's almost like combining these two expressions. They're not like terms. They just aren't. All right. Second, the 3 is a rational number. The 2 times square root of 2 is an irrational number. All right. So again, I can't combine them to make them into 5 root 2 or anything like that. All right. But we'll just leave our answer like that. Pause the video now and write down anything you need to. All right. Let's clear out the text and let's review the quadratic formula. Here it is. So if we have a quadratic equation rearranged so that it's in this form, ax squared plus bx plus c equals 0, then that equation will always be solved using this formula, the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now it's important that you memorize this formula. Memorize it, and that you have it all correct. It can't be positive b plus or minus. It can't be b minus 4ac, it has to be b squared. It certainly can't be b squared plus 4ac, that would have huge ramifications. So even though it's kind of an abstract formula, it's important that you do what you need to do to memorize it. I'm going to clear the writing out though, and let's do a problem with the quadratic formula. All right, and I'm going to keep having it on each page just so that we see it, we substitute, etc. But at some point, you got to memorize it, right? Exercise 2 says, using the quadratic formula shown above, solve the equation from exercise number 1. State your answers in simplest radical form. So we're literally solving exactly the same one that we had before. And remember, before we had the solution 3 plus or minus 2 root 2. Let's see if we get the same thing. Well, we have to know what a, b, and c are. A is always the coefficient multiplying x squared, and it's often 1, but not always. A is 1 here. B, on the other hand, is negative 6, and c is also 1. All right, so A, B, C. Let's do it. X equals negative B, negative negative 6, plus or minus the square root. I'm going to put that negative 6 in parentheses. Negative 6 squared minus 4 times A times C, all divided by 2 times A. So this is always your first step. Just faithfully and carefully inserting all of those coefficients into where they go in the equation, in the formula, sorry. Now let's do some simplifying. Okay, first thing, negative negative 6 is positive 6, plus or minus. The number one place people will mess up the quadratic formula more than anywhere else is right here, okay? Because they'll maybe type this into their calculator, and their calculator will tell them negative 36, which is crazy. Negative 6 times negative 6 is positive 36. So if you absolutely, positively must use your calculator to square a negative number, if you absolutely have to, put that negative in parentheses. If the numbers are small enough, I would encourage you to do it yourself. So that's 36. 4 times 1 is 4. And of course, 2 times 1 is 2. Let's keep going. Obviously, what's underneath the square root simplifies to be 32 divided by 2. Now, not simplest radical form, and we're fairly sure we should be getting this answer. So at this point, what I'm going to do is I'm going to simplify that radical. I can simplify that into the square root of 16 times the square root of 2, right? All divided by 2. And now I can make that square root of 16 into 4. So we're getting pretty close, but one last little piece, right? I can now distribute that division, right? So I can distribute the division to the 6 and distribute the division to the 4. I do not distribute the division to this 2. 6 divided by 2 is 3, and of course 4 divided by 2 is 2. And there we have the answer. And it was the same one we got before, which is good. Otherwise, something weird would have happened. All right, so take a look, take a moment, pause the video, and write down anything you need to. Okay, I'm going to clear this out. Let's keep going. All right, exercise 3. Which of the following represents the solutions to this equation? Well, pause the video now and take a shot at plugging all the numbers into the quadratic formula and simplifying them. Okay, let's go through it. Again, first things first, let's identify A, B, and C. A is again 1 in this problem. B is again negative, and it's negative 10. And C is 20. All right, so let's do it. Let's do negative B. So negative negative 10 plus or minus the square root of negative 10 squared minus 4 times A times C, all divided by 2 times A. Again, being careful. Negative 10 squared is positive 100 minus 4 times 1 times 20, which would be 80. That's going to be 10 plus or minus the square root of 20 all over 2. Now we have to be careful. Many of these answers have been kind of put there to try to catch us on common algebraic mistakes. So for instance, it would be tempting to divide 10 by 2 and get 5, and divide 20 by 2 and get 10, and think the choice is choice 1. But it's not. Never divide a number outside of a radical into a number inside of a radical. Okay, just don't do it. It doesn't work. You got to get the numbers outside of the radical. So I'm going to simplify root 20 as root 4 root 5 divided by 2. That's going to be 10 plus or minus 2 root 5 divided by 2. And now I can distribute that 2 into both the 10 and the 2. And that's going to be 10 divided by 2, which is 5. 2 divided by 2, which is 1, so I'm not going to write it. And I just get 5 plus or minus root 5. Kind of a cool answer. All right. Pause the video now, and we'll move on to the next sheet. All right. Backside of the sheet. Let's take a look. Okay. So, one thing that has happened so far as we've done these problems is we keep getting these answers that are irrational numbers. One type of irrational number is when we're left with a non-perfect square underneath the square root. That is an irrational number. All right, but we could certainly have rational answers to these solutions, so I don't want you to get the feeling that you can't. So what I'd like to do is take a look at solving a quadratic equation in two different ways. One way I'd like to solve it is by the use of factoring, and the other way with the use of the quadratic formula, in other words, the zero product law. So what I'd like you to do is try to solve this problem in both ways, both by factoring and by using the quadratic formula, and then we'll go through it. Pause the video now. Alrighty, let's take a look. Well, the zero product law says that we've got to be able to factor this, and this one's a little bit more challenging to factor because that leading coefficient is not 1. It's going to be 2x and x. And remember our intelligent factoring. The 6 could be 1 times 6. It could also be 2 times 3. Whoops, how about 2 times 3? But either way, you can't put another even with the 2 because then there'd be a GCF. So let me try 3 and 2. Will that work? I'll get a 4 and a 3. That'll be 7. That's not going to work. Okay, so I'm going to get rid of that and get rid of that. All right, so let me try the 1 and the 6. The 1 would have to be here. The 6 would have to be here. That'll give me a 12 and a 1. Yeah, I can make that into an 11 by doing this, right? 12x minus 1x is 11x. So then we'll get 2x minus 1 equals 0. I'm sure you can solve that in your head. X equals 1/2. And then we'll have x plus 6 equals 0. And we'll get x equals negative 6. All right. So let's use the quadratic formula and make sure we get 1/2 and negative 6 as well. All right, let's take a look. In this case, a is no longer 1, a is 2, b is 11, and c is negative 6. So let's do it. Negative b plus or minus square root. Here it's not as dangerous because b is positive, but there's another little piece that's going to show up for the first time in this problem, which is this double negative. 1 there and 1 there. Now again, if you put all of this in your calculator, it's no big deal. You know, you might not even notice the double negative. But you've got to put this all in your calculator correctly. And you could do it all at once. There's no question about that. And if you do, all that stuff under the radical becomes 169. Now, unlike the other problems that we've done so far, 169 is a perfect square. So we can actually take its square root entirely. It just ends up being 13. Now, what's cool about this is we get two answers, right? We get negative 11 plus 13 divided by 4. And we get negative 11 minus 13 divided by 4. So let's do it. Negative 11 plus 13 is 2 divided by 4, and that gives me 1/2. And then negative 11 minus 13 is negative 24 divided by 4, and that gives me -6. And we get the same answers. Woohoo! So the quadratic formula is wonderful. Doesn't mean you can stop knowing how to factor or the zero product law or completing the square, but it's a really nice formula that allows us to evaluate and find the solutions, the zeros, to any quadratic equation. All right? Pause the video now and write down anything you need to. All right. Let's clear out the text. Keep going. Okay, so the last 4 problems that we have, okay, are just all practice problems. That's all they are. And it says solve each of the following quadratic equations by using the quadratic formula. Some answers will be purely rational numbers, meaning no square roots left, and some will involve irrational numbers. Place all answers in simplest form. Okay, so there's 4 of these, 2 on this page, 2 on the next. What I'd like you to do is pause the video now, work on these 2. When you're either done or you feel like you can't get any further, unpause the video, we'll go through those 2, and then we'll do the same on the next 2. Pause the video now. Okay, let's go through them. Now again, up front, I don't know. I might end up having completely rational answers. I could have some irrational answers. All right, whoops. Let's make b into 5. That's a little bit better. Here we go. X equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Great, so far so good. -5 plus or minus. Again, if you can do all this at once, that's great. If you need to break it up a little bit at a time, that's fine too. Sorry, I know I wrote those a little bit close together. It can be confusing. Oh, look at this. Underneath that radical, we're just going to have a 1, because 25 minus 24. But 1's a perfect square, right? So its square root is itself. So we're going to have 2 nice rational answers. One's going to be -5 minus 1 divided by 6. And one's going to be -1 plus 1 divided by 6. So that's going to be -6 divided by 6, and that's going to give me one answer is -1. And this one's going to be -4 divided by 6, so that's going to give me an answer of -2/3. So nice rational answers. Okay, who knows? Maybe letter B will have rational answers, maybe it'll have irrational answers. Let's dive into it. Okay, we're back to A equaling 1, B is -8, and C is 13. So X will equal negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. That's going to give us 8 plus or minus the square root of 64 minus 52, all divided by 2. 8 plus or minus the square root of 12 divided by 2. Let me just take a moment to say stop or store. Apparently that's supposed to be a P. Beautiful. Stop at this point for a moment. All right. This is kind of moment of truth. This is when you look at this number and you say, is that a perfect square or not? If it is a perfect square, like it was in letter A, kind of all is good with the world. On the other hand, if it's not a perfect square, and it isn't here, that's when you have to start doing the kind of annoying simplification process, right? You have to say, well, radical 12 is radical 4 times radical 3. Then radical 4 is 2. And now I can distribute. 8 divided by 2 is 4. 2 divided by 2 is 1. So those are my final simplified answers. 4 plus or minus the square root of 3. Simple enough. Pause the video now, write down anything you need to. Okay, let's clear out the text. Let's do a couple more exercises. Again, what I'd like you to do is pause the video now, make an attempt at both of these, and then we'll go through them. All right, let's do it. What do we have here? A is 2, B is negative 2, and C is negative 5. All right, so X is negative B. Notice how I'm just immediately making that a positive, plus or minus B squared, which is, got a little fly in here, which is 4, minus 4 times A times C, all divided by 2A. So, simplifying the number underneath the radical, again, watch out, double negatives there, all right, end up giving me a 44 under the radical, and then a 4 down here. Again, this is that point where I always encourage you to stop and look at that 44. Is it a perfect square? And the answer is no, which is a little unfortunate, all right? But we can break it up as the square root of 4 times the square root of 11, all divided by 4, which will be 2 plus or minus 2 root 11 divided by 4. Now, how do we go about simplifying this at this point? And that's a really good question. I would encourage you to rewrite it like this. All right, that really ensures you distribute that 4. Now again, 2/4, well, that's 1/2. And plus or minus 1/2 root 11. I think this is a good way to write it. Sometimes you'll see it as 1 plus or minus root 11 all divided by 2. Right, so we'll just common denominator, put the two fractions together, and that's it. All right, let's look at D. Here we have A is 5, B is 8, and C is negative 4. So X will be negative B plus or minus B squared, which is 64, minus 4 times A, almost looks like an A, times C, all divided by twice A, negative 8 plus or minus. All of that simplifies to 144, all divided by 10. Now again, here's where you sort of stop, you pause, and you say, well, that 144, is that a perfect square or not? And the answer is it is. So we're going to get negative 8 plus or minus the square root of 144, but that's just 12. All right. So, great, we have negative 8 minus 12 divided by 10, and negative 8 plus 12 divided by 10. What do those equal? Negative 8 minus 12 is negative 20 divided by 10. Ooh, that turns out really nice. Negative 2. And then negative 8 plus 12 divided by 10, well, that's going to be 4 divided by 10, and that's 2/5. So nice rational answers. There we go. All right. So some practice with the quadratic formula. Very basic, nothing all that applied or all that interesting, just solving these equations, making sure we can substitute the numbers in, evaluate, simplify, etc. Okay, pause the video now, write down anything you need to, and then we'll finish up the lesson. All right, let's clear out the text and finish up. So this was a very basic review lesson. What does the quadratic formula look like? What is its purpose? What can it do for us? What are some of the pitfalls? And how do we simplify it, right? How do we simplify? How do we evaluate it? Most of this material you should have seen before. And we're gonna work with the quadratic formula a little bit more in the next lesson just to make sure you definitely have it. All right. For now, I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.